The center of activity for Atlas research, development, and integration has shifted to the new astronautics plant in San Diego. A summary of plant operations for the period covered by this report will be given by Charlie Ames, Chief Project Engineer.
During the second quarter of 1958, contractors were putting the finishing touches to construction as our heavy equipment began moving into the manufacturing building. During this time, missile fabrication and assembly was continued with little interruption at Convair Plant 1. Here, the move is planned to coincide with the transfer of the various missile sections. Tooling has been moved out following the completion of its use in fabricating Missile 13B. There are a total of 13 B-series Atlas missiles, all of which have reached final assembly or have been released into the test program. We reached a program milestone with the arrival and initial fitting operations for the General Electric nose cone. This was fitted to the engineering evaluation article, Missile 2B. On June 24th, Convair Astronautics made local history with the move of the hydrostatic test tower from Plant 1 to the new site. The tower, 34 feet square, 80 feet long, was the largest to ever be transported in this area. Arrival was on June 27th, near the end of the quarter. Raising of this structure into position coincided with the shift of major tank fabrication to the new plant. At the end of the quarter, we are in production on C missiles here. In the first docks are missiles 1C, 2C, and 3C. Evaluation of advanced components and systems is the responsibility of Dick Campbell, Chief of the Test Laboratory.
In the engineering test lab, ground testing activities were delayed only slightly during the quarter by the group's move to the new site. Involved during the transfer were over 90% of our facilities and personnel. Here, at the new astronautic site, the bulk of our labs have moved into the new quarters in Building 4, in the background. Our newest facility is the gas flow lab. Full-scale test operations are expected early in August. At Point Loma, a major portion of our systems test lab operations are carried on. Here, the C-Series liquid oxygen tank bulkhead undergoes a burst test. Liquid nitrogen is substituted for liquid oxygen, and the tank is pressurized to its limits. The amount of burst pressure is recorded, and the resultant damage is examined to find flaws, if any, in construction. At Tower B, during this quarter, we ran some follow-through tests with the C-Series liquid oxygen elbow. To observe the flow characteristics, cameras were placed in various locations on the test specimen. Engineers examined the film, looking for any signs of gas entrainment or vortexing, undesired phenomena possible with high flow rates. Facilities here permit us to test either statically or dynamically all structural aspects of the missile system, as well as flow and pressurization tests.
B missile systems proven in the laboratory test program were subjected to simulated flight environments in static firings at Sycamore Canyon. Base manager here is Phil Gardner, who will describe Sycamore program highlights from test site number 2.
Our testing activities during this quarter centered on Stand 2. Here static tests were run on the first B-series missile. We completed Block 1 test objectives with Missile 1B. At the conclusion of Block 1 tests, we converted to Block 2. During this period, we demated 1B to make functional checks and to incorporate engineering changes.
The demating had only been performed horizontally in the factory prior to the vertical demating at Sycamore. On June the 18th, Missile 1B was scheduled for a long-duration firing. At 4:38 p.m., verniers were ignited. After vernier start, a fire was noted on the television monitor in the blockhouse. Immediately, the fire exit system was operated, extinguishing the fire. The resultant damage, which was limited to the thrust section, was examined and test data studied. The missile underwent repairs and was returned to S2 to complete its test plan. At Stand 1, C-Series conversion tests had progressed satisfactorily at the end of this quarter. Lines were reworked, the launcher modified, and changes made on the tower to permit separation. We revised the flame bucket from the former jet-cooled operation to the spray type. Similar types have proved highly successful at S2 and Edwards Missile Static Test Site. The major portion of C-Series conversion tests were electrical. The wiring was re-engineered to enable technicians to make changes and repairs more easily. Almost all our recordings will be made on the FM system with magnetic tape tracks. After a run, these tapes will be processed at data processing labs nearby at the new site. All conversion tasks will be completed by August, and we anticipate the arrival of the first C static test missile during the second week in September.
Missile runs were also conducted at Edwards Air Force Base Missile Static Test Site in California's Mojave Desert. The base manager for Convair Astronautics at this site is Jerry Jeremiah, formerly served as Chief Test Conductor for Atlas flight tests at AFMTC.
During this quarter, we've been active in many phases of test operations. Test stands were modified for advanced series test articles, and construction continued on new facilities. Hot firing tests with Missile 14A at Stand 1A were completed early in the quarter. A milestone was accomplished April the 9th with the successful completion of 2 full-duration runs. Missile 14A was removed June the 11th with a total of 1,113 seconds of main stage in 13 tests. We are now converting this stand to C-Series testing. At Rocketdyne Stand 13A, Convair Astronautics propellant utilization systems tests were being run. This system is to provide minimum amounts of propellants on board at burnout. It is also capable of correcting tanking errors. At Stand 14, we completed rework on the stand and related facilities in April. Plans to resume testing began immediately. The test article for this stand was the combination BC series propulsion system. The engine configuration for the first series of tests was the B series. The first hot firing was June the 6th.